All right, guys, let's take a look at this final example. Now, before we do, you're probably just looking at this thing, wow, that's a lot of information. Well, truthfully, a lot of it is just there to provide context. And so we can actually skip through a bunch of it as far as what is important, but I think it's important to actually kind of read it. So let's read it. It says Henry was interested in seeing if adults are more generous towards homeless people based on their political leanings. Henry believes Democrats will be more likely to donate more. Henry wanted to account for how much they would be willing to give based on how much that they made. For instance, he would assume that somebody who makes $100,000 per year to be more capable of giving than a person who makes under $40,000 per year. Henry used the ratio of donated money over salary to create his data points. For instance, if someone was willing to donate $100 and they made $100,000, their data point would be 100 over 100,000 or 0.001. Henry collected samples from 15 Democrats and 15 Republicans and found the ratios to be 0.00194 for Democrats with a population standard deviation of 0.00011 and 0.00187 for Republicans with a population standard deviation of 0.00016. To make these numbers easier to work with, Henry multiplied all values of average and standard deviation by 100,000 so that they instead read Democratic average 194, standard deviation 11, and Republican average 187, standard deviation 16. With an alpha level of 5%, can Henry confirm that Democrats are more charitable than Republicans? All right, so what I did was I took that exact information and put it right over here. And you'll actually notice that right about here, all the way to here, is just to provide context. So what I'm going to do real fast is we are just going to take all that information and get rid of it. So suddenly we're dealing with all the important information here. We understand that we need to create our hypotheses, and then we'll be able to grab all the other information afterwards. So let's start with the hypotheses. It says, Henry believes Democrats will be more likely to donate more than Republicans. So what we're going to do is let's go and call Democrats 1 and Republicans 2. What he's saying is that the average money that Democrats are willing to donate for homeless people will be greater than the average money Republicans will be able to donate. So if we call Democrats 1 and Republicans 2, we're saying the mu of 1 will be greater than the mu of 2. So let's go ahead and write that down. So again, mu of 1 will be greater than the mu of 2. All right, we also know that to create a null hypothesis, we just need to take our alternative and flip the sign and put a line underneath. So we're going to flip this instead of greater than, we're going to change it to less than or equal to. So less than or equal to. All right, we also note that the claim was our alternative. So this is our claim. And we also know that this is going to create a right tail test because it's pointing to the right. It says greater than, so it is pointing to the right. All right, next up, let's find our alpha level. Well, that's actually pretty easy to find. It literally tells it to you on the last sentence there. An alpha level of 5%. So let's change alpha level to 5%, which we know is 0.05. And for those of you that have spent time looking at the Z chart on the negative side, you know that a 5% alpha level always gives us the same Z score, or Z alpha as I like to call it. So Z of alpha is going to be equal to 1.645. And you can feel free to look that up if you don't believe me. Now, if you actually look up 5% on there, it is going to give you negative 1.645. But we also know that our claim or our alternative hypothesis is pointing to the right, so it has to be a positive number. So this is a part that can get a little bit tricky, but make sure that if it's a right-tailed test, which we said it was based on our hypothesis, that this has to be a positive z-score. All right, moving on. Our mu1 and our mu2, we've stated before that these are pointless to even think about because they're going to cancel each other out. So they could be 100, they could be a million, it doesn't matter. They're identical, and when you subtract identical things, it goes away. All right, x bar 1. X bar is, of course, our sample average. So our sample average for Democrats is 194, so let's write that in. And our sample average for Republicans is 187. Let's write that in as well. All right, population standard deviation says 11 for Democrats. And it says 16 for Republicans. We know that our variance, we just need to take each of these standard deviations and square them. So 11 squared, some of you probably already know the answer to that, but if you don't, that's okay. That's what calculators are for. So 11 squared is 121. And we know that we need to square 16 as well. So 16 squared is going to be equal to, I think it's 256, but we can check. 16 squared, yep, 256. So we have 256. All right, our sample standard deviations, well, they don't give us any. They just give us the population standard deviation, which is better than the sample standard deviation. So these are pointless. Sample size, we interviewed 15 Democrats and 15 Republicans. So let's just write down those numbers, 15 and 15. That's all the information we need. Now we can start plugging stuff in to find our standard error. A standard error is going to require that we know the variance of each. Well, we found the variance to be 121 and 256. So 121, 256. And we know that our sample size for each was 15, 15, 15. So now we can solve this one. I'm just going to copy it, paste it over here. Let's find out what 121 over 15 is. 121 divided by 15 is going to give us about 8.07. So let's change this to 807. Next up, 256 over 15, 256 divided by 15 is 17.07. 17.07. Let's add these numbers up and then square root them. So we're going to add 8.07 to 1707. We're going to get approximately 25.14. So 25.14. Let's go ahead and square root that, and we should get about 5.01. This is going to equal 5.01, and that's our standard error. Now our standard error, we are going to plug into the bottom of this equation. Let's go ahead and start filling in things. X bar 1, we said was 194. X bar 2 was 187. These mu's we said are equal, so they will cancel each other out. We can get rid of them. And our standard error we just found was 5.01. All right, last step. So we just need to figure this guy out. So 194 minus 187, 194 minus 187. Will give us a 7, so 7 is going to be our numerator. And we're going to divide that by 5.01. And we get approximately 1.397. Let's call that 1.40. And this is our z-score, or our sample statistic. So we're going to take this z-score and we are going to compare it to our alpha level z-score. We're going to see if it's in our rejection zone. All right, so our sample statistic we said was approximately 1.40. And as you know, 1.645 is our alpha level z-score. So our rejection zone is everything to the right of that point. Well, 1.40 is not as big as 1.645, so it's going to be more to the left, more closer to our 0 number here. And 1.40 is not going to actually make it into the rejection zone. So what does this mean? It means we cannot reject the null hypothesis. So we cannot reject the null hypothesis. Can't reject it. And if we can't reject the null, then we can't support the alternative. So we can't support the alternative. So we can't reject the null, we can't support the alternative. Our claim was our alternative. So in other words, we can't support the claim because our claim was the alternative. And if we cannot support the claim, then we know that despite the fact of what our sample and comparing the averages of those samples showed us, it's not enough evidence. The numbers are so close together that that we can't say for certain that the population of all Republicans and all Democrats will act in this way. There's not enough evidence to prove our claim. So, quote, actually, let's put this over here. Quote, with an alpha level of 5%, we cannot support the claim that Democrats are more generous towards homeless people than Republicans. And we're done. We got the answer. All right, guys. Thank you so much for watching.